right. Hi, and welcome everybody. Thank you for tuning in here at Global Azure Austria. My name is Thorsten Hans. I'm a consultant at Thinktecture, and I'm mainly focusing on cloud native stuff and infrastructure as code using Terraform. And today, that's exactly what I want to demonstrate. We will talk a little bit about infrastructure as code with Terraform. And so I've prepared the talk and separate into four segments, let's say it that way. First, we will jump right into what infrastructure actually is and how Terraform can help you excel in that area. And then we will look into how to use Terraform in the context of Microsoft Azure. So how to craft your Azure infrastructure and mutate it over time using Terraform. Third is also very interesting. How can you automate your infrastructure as code using GitHub Actions? And for reference, I've added a couple of resources that you could consult if you would like to dive deeper into Terraform. So let's jump right into the topic. First, obviously, what is Terraform? So Terraform basically is a tool set that you can use to start diving into infrastructure as code. So it's a set of services and a command line interface that we use to automate or to automate the process of creating, mutating, and potentially destroying infrastructure that lives in different cloud areas. So Terraform is written in Go. It's platform agnostic. That means it's easy to distribute. You can just download the binary and execute it either on Windows, Linux, macOS, and other operating systems. And on top of the open source offering, there are a couple of paid service offerings like Terraform Cloud or Terraform Enterprise that gives you more capabilities when it comes to collaboration and adding governance if you have to build multiple infrastructure as code projects. However, it's not mandatory. You don't need any kind of paid or opt into any kind of paid service offering. Most of the time, and for I would say 90% of the projects I do with Terraform, we are fine with the open source offering. So just Terraform, the command line interface that we have to interact, with Azure in our case. All right. So if you dive into Terraform, then you will very quickly recognize the tagline, let's say, that HashiCorp puts underneath Terraform, that is write, plan, and create. And that's what we will look into right now. So write means actually adopting infrastructure as code, right? So taking your cloud infrastructure and describe your desired state using infrastructure as code. Plan, that's one of the key benefits that Terraform brings to the plate. That's actually previewing changes before actually applying them to your cloud vendor. So that means you don't have to be afraid that only by looking at how may my infrastructure look like in Azure, that something will be modified without you actually knowing about that. And third, obviously, with Terraform, you're able to create reproducible copies of your infrastructure and easily create, for example, dev, test, and prod environments having a single Terraform project. So let's dive into write, which means infrastructure as code. Obviously, taking or expressing your infrastructure as code, that's the first step that you take towards infrastructure automation, which may lead to something like, a fully automated DevOps process, or if you're on the road towards cloud native environments, then automating your infrastructure using infrastructure as code is obviously one of the first steps that you would take. When you create your infrastructure using code, it's obvious that you can put your code into source control, which gives you already some kinds of workflow. So all of you may know how to deal with pull requests, how to do collaboration on pull requests. And so you can see how your infrastructure mutates over time, which is also very handy if you think about, debugging, troubleshooting problems on your infrastructure level. Then you may use the backlink to your Git repository and see, okay, 2 days ago we did this change. Maybe the issue that we see in production right now is related to that change. So on top of that, if you think about a situation where you're creating your infrastructure manually, you have some kind of truck factor, right? So there's the one person on your team that exactly knows how to configure, let's say, the SQL Server in Azure to empower your mission critical product. But what happens if that person is not available for, let's say, 2 weeks or so, and you have to somehow troubleshoot the SQL Server deployment? And with adopting infrastructure as code and providing the code base to the entire team, you can get something like, for example, let's say a shared ownership. So everyone on the team should be able to read the infrastructure code, and everyone should be able to participate and contribute to the infrastructure on that level. And Terraform makes that fairly easy because the language that we use is fairly simple, as we will see in a couple of minutes. Preview changes, so the plan thing when it comes to Terraform. That's really one of the best features, if you ask me, when it comes to Terraform. So I can easily shoot a command using Terraform CLI, and that looks at the current state in the cloud and tries to identify, or it identifies what it will actually do to mutate the cloud to reflect what's defined in your infrastructure as code project. So having this capability means that you can see, okay, when you execute your Terraform project right now, targeting that particular cloud instance, or let's say that Azure subscription in our case, Terraform will tell you, okay, I have to spin up, let's say, 2 new services. I have to modify your AKS cluster. And by the way, that storage account that you don't need anymore, I will remove that from Azure when you execute that project right now. And this is really, really helpful. And you can also integrate this planning capability into your CI and CD workflows so that you can fully automate the mutation, but still get some kind of feedback where you can say, okay, on a pull request, just give me the plan. Then you can revisit the plan. You can verify if that looks good for you. And if so, you can merge the pull request on your main or master branch and finally execute Terraform apply, which will then modify the underlying Azure subscription. So basically, when we talk about the execution plan, or if you see something like Terraform plan, then you can think of it as of Git status, right? You see what will happen when you apply or when you commit those changes. Third is the create term. So that means we have one Terraform script and we can apply it 1,000,000 times, right? We have maybe we have a slightly different context. Maybe we target one Azure subscription today, another one tomorrow, or maybe we have slightly different variables that we take into consideration to spin up, let's say, one environment with a suffix of dev, one with staging, and one with production. And boom, there you go. You have 3 environments up and running in no time. Creation is a kind of critical, right? So if you mutate an existing cloud environment, we somehow have to deal with concurrency, because I or you as a member on the team, you can, there's nothing that prevents you from just applying modifications to the underlying cloud infrastructure. And at the same point of time, the continuous integration workflow or continuous deployment workflow could also try to modify the underlying cloud infrastructure. And Terraform has a concept of active state locking that prevents concurrent modifications being applied to the same underlying cloud infrastructure. So there's a level of robustness that Terraform brings to the plate that we can use to ensure that no concurrent modifications are applied to the same set of infrastructure services. All right, so basically all Terraform projects will follow the same Terraform lifecycle. So we start writing our code. So we express our infrastructure in code. Then we plan. So we ask Terraform, hey, give me the execution plan. Show me what will happen if I execute this right now. Then obviously we have to verify this plan. And if this plan matches our expectations, then we can execute Terraform apply that will talk to the cloud vendors' APIs and modify the infrastructure. And from that point in time, we and our customers are able to consume the services that build our product or our service or our project. And maybe at some point in time, you don't need the infrastructure at all. Then you can just execute Terraform destroy and delete all the services that you have previously allocated in Azure. To do so, we use a language called HCL. That's short for HashiCorp Configuration Language. The HashiCorp Configuration Language is a subset of JSON. So there are some of the nitty-gritty things being removed from JSON. So we don't have to type all those semicolons and stuff like that. And we use HCL no matter which cloud we're talking to. So right now, today, we focus on Azure. So we use HCL to express all our services that we want to have in an Azure subscription. But maybe you have to run a multi-cloud project, then you still use the HCL. However, you add a second so-called provider to your project. So Terraform uses HCL. That's the language where we write our infrastructure in. Terraform brings the concept of providers to the plate. So there are several providers that integrate with the cloud vendors' APIs. And it's in behalf or it's in charge of Terraform to instruct those APIs. The good thing is HCL is fairly easy, it's simple to learn, and you will get productive in no time. So there are only a few top-level building blocks. There are only a few types that you have to learn and care about. And yeah, that's exactly what we will use in a minute when we dive into terraforming Microsoft Azure. But before that, let's quickly talk about the Azure Resource Manager Provider, or short Azure RM provider. That's the provider that we will use, or Terraform uses, to interact, to call into Azure's ARM API. And it also gives you an understanding of what's possible with Terraform. In Terraform, you can use all capabilities that are exposed via Azure ARM API, not more and nothing less, right? So if Microsoft provides all capabilities via Azure ARM API, you can use it in Terraform. And the teams at HashiCorp and Microsoft, they are really curious about reflecting changes immediately from the Azure RM API into the Terraform provider. Good thing is, at this point in time, we have plenty of different authentication patterns that we can use. So we can start easily by just reusing existing Azure CLI authentication. That's really, really good for starting on your local machine. But if you take it, if you want to build something serious, you should consult Service Principal or Managed Service Identity to authenticate to Azure ARM. So a service principal, for example, is something that I typically use to interact with the Azure ARM APIs. And that's also the kind of identity that I use within a GitHub action to have an unattended but still authenticated call into the Azure API. All right, so let's jump into VS Code. Let me minimize my slide deck over here. And by the way, I have a live share link that's also already in the comments over here. So if you want to follow straight in Visual Studio Code, feel free to click that link, and then you should end up in the same Visual Studio Code instance as I have over here. All right, so I'm here on the Mac, and I have downloaded and installed Terraform. On a Mac, you can just simply use the homebrew manager. So let's say brew install Terraform. And then you will end up with having the latest version of Terraform installed. An advice from all the projects that I work on, there is a Terraform version manager called TFN, that, for example, gives you access to all different versions of Terraform. And so you can easily switch between Terraform versions depending on the project you're actually facing. But for now, I have installed Terraform, let's say, version. I've installed 0.15.0, so that's the latest version that has been released yesterday, I guess, if I remember correctly, yesterday or the day before. So that's the only dependency that we have that we need. And then let's jump right into terraforming some Azure resources. So as I said, we need the Terraform. We need the Azure provider in our Terraform project. So I've already installed the Terraform provider just to save not mess up the time with writing those lines over here. So I registered the Azure RM provider with default feature set, and to be a little bit more robust, I explicitly pin the version to the currently available version. So if there is an upgrade, I have to revisit my project and say, hey, I want to adopt the new version, let's say 2.60.0. So this is just good practice to do it if it is a real world project. Once you have registered your provider, once you have optionally specified the version, so pinned the version, you have to execute something that's called Terraform init, that initializes the project. Let's execute that one, Terraform init. And there we go. You see, it's pulling down the Azure RM provider and installing it into our project directory. And by the way, every folder is a valid Terraform project. Or everything you need is a .tf file. And no matter how you organize or structure your project, Terraform takes all .tf files in the current folder into the context. So we'll see in a couple of minutes, we will rearrange, refactor things to have some kind of structure in our project, but there's no special requirement, right? There's no project file or something like that. It's just a bunch of TF files. So let's keep things simple. So in Azure, everything is some kind of, grouped into resource groups. And that's the first resource that we will describe right now. So in Terraform, if you want to create or mutate something, we call it a resource. And a resource needs a type. So there are different types available. Let's take a resource group and give it a name. Name is a kind of identifier that we use within the project, to reference properties from a resource. Let's say this is our main resource group. The main resource group obviously needs a name. Let's say global Azure AT. And we have to specify a location, let's say Germany West Central, in my case. There are plenty of other properties that we can set, and those heavily depend, on the type of resource. And by the way, I have installed, let me quickly bring up the extensions. Let's look for Terraform. I have installed the official Terraform extension over here. And you see the underline over here, that's Terraform links, I guess. Links, somehow is it called? Terraform documentation links. That gives you this underline, and by holding Command and click, I can, let me bring up this one, immediately jump right into the documentation of the particular resource. So right here, I'm in the documentation for a resource group, and I can see, okay, I have to provide a name, a location and a name, and optionally, I can set Azure Tags on that resource group. Okay, so let's do that. Let's bring back Visual Studio Code, and let's say we want to, let's take this one over there. So we want to specify some tags, and let's say that's com.azure global azure .session equals Terraform to add a custom tag on that resource group. And for the scope of this session, I want to deploy a Kubernetes cluster. So let's say resource Azure RM Kubernetes cluster. Let's call that AKS. And obviously, AKS is a fairly complex service in Azure, so it has plenty of configuration values, right? You see add-on profiles over here, autoscaler profile. So a real huge list of configuration values that we can set. But let's keep things simple. Obviously, we need some kind of name. Let's say that's my AKS dev, my development cluster. And it has to belong to a resource group. So I can right now obviously copy the name of the resource group and paste it over there, but we don't want to repeat ourselves, and that is an error prone, right? So if I do a mistake over here, the Kubernetes cluster won't be deployed because the resource group is not there. So we can obviously reference values from another resource by saying, hey, look at the Azure RM resource group with the name main, and from there take the name. Nope, not container name, name. So we can obviously do the same for the location. So instead of, again, writing Germany West Central, we can bring in the location from the resource group. But there's still something more. We can add a variable to our project so that we are able to, configure that value in runtime. So for example, that we can say, hey, right now I want to spin up a development environment. So I could specify another value for the resource group name or for the location. Let's do that for location. Let's say variable location. That's a type of, string, and it has a default value of Germany West Central. And we can obviously add some description over here. Where should all resources be generated? And then we could get rid of the magic string over here and use the variable over there. We could also use the same variable over here. However, it's a good advice to have all resources of a resource group in the same location. So that's why I always reference the location from the resource group. By the way, tags. I mean, perhaps we end up with something like, let's say, like this. And maybe we want to, modify the com.globalazure.environment tag to say at some point, hey, this is our staging environment. How can we do that? Well, obviously, we can bring in a new variable, right? We can say, let's call it custom tags. That's a type of map, and the default value is empty, or we can use the set of variables that we have over here. And let's add a quick description, add some custom tags associated with every resource. However, maybe I want to have a slightly more robust configuration. So Terraform also knows something called locals. And the difference between variables and local variables is that local variables can't be changed from the outside. So variables can be specified either via a so-called variable file. That's just a file, listing all the variable names and the values. We can specify it via CLI, or we can, define an environment variable, and Terraform takes that into consideration. However, locals can't be modified outside of the .tf files. So that's fairly good for building something like default tags, right? So we can take those tags from the resource group over here, put them over there. Let's say we want to default to development, but what should we use over here? Somehow we have to combine the custom tags with the default tags. So the solution is fairly easy. We can say we have another local variable called tags, and that's just a merge of our default tags. So we take them first, and then we merge into the existing map the custom tags. So let's say var custom _ tags. And this means that if I, for example, say, I specify the custom tags as com.globalazure.retention and say, for example, keep forever, I would end up in tags having 3 tags, right? I have the com.globalazure.retention, session, and environment with their corresponding values. However, I can also specify this, like environment equals staging. And because custom tags is applied as last argument, staging will override development. So I will still end up with having 3 tags, but right now the value for environment will be staging instead of the default value that I specified in the locals. So this brings some flexibility to your Terraform project, right? But you can still govern and ensure that a certain set of tags is associated with all resources. But for now, let's get rid of them. And let's use our new local variable tags over here by saying local.tags. And by the way, so Terraform is written in Go, and Go is very opinionated when it comes to how source code is formatted. And this also applies for Terraform and its scripts. So there is a format or command built into Terraform command line called Terraform FMT that iterates over all the files and prints the files that it had to reconfigure or reformat to match the desired format. So it's very opinionated. You don't have to care about how developers or how your colleagues, structure the source code. You can just format it by relying on the default format command. Okay, at that point, it looks a little bit, messy. So we should split up things a bit. So I tend to, have at least the variables in a separated TF file. And depending on the service that you're actually using, you may end up with multiple variable files. So let's put the variables over here and the locals. Yeah, maybe from time to time I have a locals file, or I take this also into the meta file, because it's a kind of default value, right? All right, so my main file can actually focus on the resources itself. All right, so let's try to get our AKS up and running, right? So obviously AKS needs some other properties being specified. So we need a DNS prefix, right? Let's call that also AKS. And we have to specify, quickly reformat that one. We have to specify how the AKS or how many virtual machines should build up our Kubernetes cluster. And by default, there's one node pool in the cluster, and we can specify the name for it. And let's call it Linux. And let's say we have a node count of 2, and we have to specify how many or which VM virtual machine template actually or size should actually be used. And let's say standard _ DS2v4 is, if I recall, on AZVM list. That's, I think, a valid and properly sized VM. Let's quickly dive into the list of sizes that are available in Germany. So D2V4, that's 4 cores and 8 gigs of RAM. Yeah, that looks good. Just to ensure I didn't. Okay. D2, oh, DS2. DS2, what's DS2? Doesn't matter. DS2V2. Okay, this one has a gig, has slightly more RAM, so that's okay. Next, our AKS should be executed using service principal. So we have an identity block over here, and let me quickly close this one. And we can say the type is system assigned. Right, so Azure takes care of creating and managing the underlying service principal. There, you can also use user assigned over here, but then we have to, create another resource of type managed Azure or user managed identity. But let's keep it simple for right now. And in AKS, we can enable, disable different add-ons. So, for example, there's the Kubernetes default dashboard, right? My intention is we can just disable it because we don't need, these pods being deployed into kube system, having a route that, or having a service that routes the traffic into that pod, because Azure is, maturing that area a lot, and you see slightly a ton of insights of your AKS cluster right in Azure portal. So that's also very good. I think let's give it a try. But instead of just, invoking the script, let's do Terraform FMT again to have everything in place. And then there is Terraform Validate. That looks at your configuration and tries to spot some misconfiguration, like I have over here. Okay, so there is in the meter.tf line 7, there's a mistake. What's up over here? Com dot. Oh, okay, I think I have to specify like this. Let's validate again. See if it's happy. Now it's happy with my configuration. Okay, so what's now? Now I can say, hey, Terraform, just look at my Azure subscription and tell me what will happen if I execute this project. So I can do a Terraform plan. So this takes several seconds, right? It talks to the Azure ARM API and examines the actual state in the cloud. And finally says, okay, there's nothing, there seems to be nothing in the cloud, right? I have to spin up, let's scroll through that. So there was my plan invoked. I have to spin up the Azure Kubernetes cluster, and a lot of properties will be known at the point when creation has been finished. And I have to also, I think it has to spin up the resource group, right? Because it's not there yet. And as you can see, the tags will be applied to all of the resources. So I see, okay, 2 resources will be added, no will be changed, no will be destroyed. Looks good? Well, not yet. Let's first adopt another concept in Terraform. This is great to, as a playground project to get started, but how can you actually build a real world project? There's a concept called Terraform Workspaces. By default, in a new project, you end up with having the default workspace. But as you can see, I already created a development, a staging, and a production workspace. And what a workspace is, every workspace has a dedicated state file. So they are tracked independently from each other. However, they are somehow similar, right? Maybe they have like different variable values being set. Maybe they have different names, or you decide to just run your production AKS using the paid SKU. So that gives you kind of flexibility. But yeah, that would resist in a name clash, right? If we deploy to the same Azure subscription in 3 workspaces, we would end up, the first one will be applied successfully. But if we switch from development to staging and ask Terraform to deploy all the resources, the Azure will obviously, throw an exception, because there is already a resource group with the name rg-global-azure-at, and the same for AKS. There is already an AKS with that name. So we can bring in some simple string interpolation over here. So we can reference the name of the workspace by saying, hey, Terraform, what's your workspace name? And having this syntax right now would lead to, let's switch to development, Terraform workspace, select dev. Okay, switch to dev. Let's list it again. There we go. You see, we are now on the development workspace. So this would result in having a name of RG Global Azure AT Dev. And if we move on to staging, we would end up with staging and production. So we have nice aligned, naming pattern in our Azure subscription. And let's do the same for AKS. So we have dev already over here, but let's say this is, oops, not a percent, it's $, Terraform the workspace. And there we go. Okay, so this looks good. Let's say Terraform plan. Again, give me the execution plan. Show me what will happen if I execute it. Okay, add to, and we see the resource group. The name will be at-dev. So we are in a dev workspace right now. That's okay. Say Terraform apply. Let's talk to the Azure APIs right now. Terraform apply will again print the execution plan. However, in CI or CD workflows, you can add an argument called -auto-approve to get rid of this prompt over here, and so you won't see the execution plan at that point in time. Okay, so spinning up an AKS takes a couple of seconds, minutes. That depends on how many creation or deployment operation are currently happening in Azure. But if we take the Azure portal next and let's refresh the view, it can take several seconds up until the resource group pops up over here. But in a few seconds, we should see our development resource group appearing. And we should get, let's set that next to like this one. So we see resource group creation completed after a second. AKS is still creating, but still, there we go. There's the dev subscription, the dev resource group. We see the AKS is already here, but it will be in a state creating. Yeah, okay. So that will take a couple of seconds. But instead of waiting for it, let's bring back, there we go. Let's bring back the slide tag. So what we've seen right now, we have seen how to, create a simple cloud environment, right? We have just a resource group and an AKS, how to use Terraform resources, variables, locals, and we have slightly touched Terraform workspaces to, create reproducible or to manage multiple environments with a single project. Next is how can we move further towards automated infrastructure. So Terraform has or offers a so-called action that we can use in GitHub Actions to install a certain version of Terraform in our CI process, and then we can just use regular bash script or the script activity, the script action to invoke our Terraform commands in the CI pipeline. Right. Same applies for Azure DevOps. If you're using Azure DevOps, there's also an install Terraform or install tool, Terraform tool task, how they call it, I guess. So it works either on GitHub or on Azure DevOps. So no matter which one you're running on, you can use Terraform and fully automate your infrastructure provisioning. Obviously, I mean, I use a service principal. So locally, I've stored the client ID, client secret, the target subscription ID, and the Azure tenant ID in an environment variable. If you're using GitHub, then there are repository secrets that you can use to establish the context to get the authentication or the required bits that you need to spin up the authenticated calls to Azure. And a small hint, so if we go back to the terminal over here, you see there are some, green plus symbols over there. If something is deleted, it's a red minus. So this becomes fairly hard to read because GitHub Actions or Azure DevOps, they don't print colorized output. So maybe you end up in seeing the color code representation. So something like \C or M, blah, 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 the color code in the logs. But Terraform addresses that by giving you a no color argument. So if we look at a GitHub action, how you can automate the provisioning from an infrastructure written in Terraform. So obviously, I mean, we specify when this CI or this GitHub action should be executed, and we create a job and we say, okay, I want to run this one on Ubuntu in my case, and then I have to specify some environment variables. So Terraform looks at those environment variables, ARM client ID, ARM secret, client secret, and so on and so forth. And I fill them by using the GitHub repository secrets, right? And then I use the official setup Terraform action. I specify the version of Terraform that I want to use, 0.15.0 in my case. And then I, make my way through the Terraform lifecycle. I initialize the project. I check the formatting. I validate the project. I plan the project. And if I'm on the main branch and it is a push to the branch, then I execute Terraform apply with auto approve so that there's a fully automated way from a code push to GitHub towards my Azure subscription. Make sense? So let's take a look at the repo again. Settings, secrets. There are my secrets, right? I've configured them. I've put all my sensitive information over there. The action, I executed it previously already, but it's right now, it's still creating my AKS cluster. However, that should be done in a second or so. But let's bring up a new terminal. And let's take a look at what happened here. Let's say git add everything, git commit dash live coding. And the good thing is this GitHub action does not care about the workflow, right? About the workspace. So there, I didn't put workspace set or workspace select dev over here. So if I push right now to GitHub, let's take a look at the workflows, and there should be the live coding action. And it starts initializing the project. It pulls the Azure provider. It plans the project. And planning the project means that it will recognize, hey, what it has to do. Let's bring up the plan again. And let's just look at the resource group. Because I didn't specify the workspace, it's running on the default workspace. And so once apply in GitHub has finished right now, we will end up with having two independently managed infrastructures from a single code base. In the meantime, let's quickly check if the first, what's happened over here? Continuously retry. Okay, maybe that, was unexpectedly long until AKS made its way to the status of running. But we will quickly check this one. AKS. Oh, it's in failed. That may be due to a mistake in my subscription. However, we'll give it a try in the second infrastructure. That should be up and running in a second. But let's cycle through the other two slides that I have. So if you want to dive deeper in Terraform, I will send the slide deck. There are a couple of open or free resources that you should consider looking at to dive deeper into Terraform. And there are also some, there's a good book, Terraform Up and Running, that gives you all the insights that you need. And there are several free resources like best practices available that you could consult in to learn more. Thanks for tuning in. If you have any further questions, don't hesitate. Use Discord here at Global Azure AT, or just shoot me a tweet or a mail. Ask your questions. I'm happy to assist and help you grasping more with Terraform. Thank you.